In last lecture, we discussed about volume of a spherical object. Now, how to determine the volume of spherical or circular nature object. There are few methods. Revolution, because the solid object is revolving about the x-axis or y-axis, and we can get a three-dimensional measurement of it in terms of its volume. So there are three methods of this. First one is the disk method. I already explained it. For example, in case of oranges, if we want to know the volume of orange, what we need to do, we need to slice up the oranges into too many slices and determine the volume of each slice, and by summing up all the slices, we are getting the volume of orange. And in this disk method, you can say that axis of rotation, this axis of rotation of course is part of the boundary of the plane area of, you can say that it's the part of the complete orange. However, in washer method, remember it's the second method. In this second method, the axis of rotations are not counted in net volume of the object. In third case, cylindrical method. In the example of washer method, you can say, for example, tire of a vehicle. We don't need to determine the volume of complete solid things in terms of a tire, but outer volume of a tire, you can say, on the rim, we say it's a tire, but rim is the another part of a tire body. So the washer method is used there. In cylindrical method, it is almost similar to the disk method, but in this case we are considering the object in form of a cylinder. These cylinders are not exactly should be in form of horizontal nature, like this one is a cylinder. So of course it's height h, and if we are talking about this base area, pi r square, and of course its volume, if the top side is open, the volume becomes pi r square h, or you can say base into height. Base is some kind of area in terms of circular region. So it's a cylinder, but the nature of this cylinder is gradually, you can say that, decreasing. For example, here in this case, we need to determine the volume. So this volume, of course, not in a uniform, cannot be determined with the help of simple formulae of a cylinder. So we need to divide, or we need to slice up this volume of a cylindrical nature in terms of shells. There are too many shells. For example, this one is the first shell, inner shell, so too many shells. So we are determining its the volume of each shell, and by summing up all the shells we are getting the net volume. Here in the disk method, so of course the central part is also axis of rotation are also part of the complete volume. So we are slicing up, in case of oranges, as I said in start, we are slicing up the orange into many slices, and this one slice surface area representing its circular region, and its thickness in case of this is representing with the help of dr. So we can say the volume of this slice will be added up with all the other slices, and we can determine the net volume of a orange. I already explained in lecture number 26. On FARCIM. You can check out the YouTube. So here today I would like to explain the method of shell. See, as I told you people, there are too many shells, too many cylinders. Cylindrical that was related to the shell method or cylindrical method. This one is the smaller cylinder, bigger cylinder so they are concentric with one another, and we are getting this kind of shape, and each shell is giving us some volume, of course. So for determining the volume of a shell, what is the important thing? Important thing is we are unwrapping each shell. This is representing its circumference, and of course height of each shell is representing with h, and the delta x is change, or you can say thickness of the each shell. This is the unwrapping formation of a cell. So there are two issues. First one, radius is ambiguous from center to outer layer, and the other one is the act of unrolling. At which scale it is unrolling, these both things are not defined correctly, so we are using the integral in order to determine the net volume in somehow good approximation. For example, here we have a tissue roll. See, this tissue roll have two main layers. One is the inner layer. Let me mark this inner layer with blue color, and other one is the outer layer. Let me mark the outer layer with green color. See, if the outer layer, if we are unwrap the outer layer, for example, this one is of greater size than the inner layer. Though height of both sheets, this one is the tissue layer at the outer scale, but height is the same. This one is the inner. See, length of both the layers are different. Inner layer has too short length, while the outer layer is having a bigger length in comparison to the inner layer. So gradually there are too many, you can say that, layers inside of it. However, the radius is not defined properly for each layer, and it is gradually changing. Moreover, the behavior of what? Unrolling. This unrolling behavior is also not defined. So radius and behaviors are ambiguous in this case, because somehow, for example, here at each instant they are changing. So we need to apply the integral, and this can be done with the help of washer method. See, we are slicing up this layer to layer here. Why? Because central axis is not involved in its net volume. Here you can see the volume between two curves. Okay, on the, if we are talking about on the x-axis, both are the sampling we are slicing up on the along the x-axis. Of course, this is should be in dx, and of course from one point to another on the x-axis, and we are getting it. Or if we are slicing up along the height, then we will consider the dh, and we will get the difference between two layers, outer layer and inner layer. Difference is determining the volume of an object in terms of washer method. However, this one is the representing the washer method. Here see the inner rim, this steel body is not included. Steel body is not included. Only the black layer. This you can see that the tire, this yellow color, this is including in it, and this is the volume of a tire can be concluded only that is volume of the tire is concluded with the help of this yellow region. So this is the inner axle of the blue color will not be, or you can say rim will not be included in net volume of a tire. So it can done with the help of washer method. Further, because in the washer method axle is not included. Here the height, okay, because sampling they are reading its sample, but so this is the outer layer, this one is the inner layer. So let's talk about the comparison between the disc and shell methods. This onion is composed of too many shells on one another. See, if I cut the onion, we can see that there are too many shells on one another. See, this is the, you can see inner part, outer shell, the more outer shell, the outer shell. So all shells are placed on one another, and if we can determine the volume of one single shell, this is the, you can say, height, and this one thickness of the each shell. On the x-axis it is representing with the help of dx as a sampling interval. So by determining the volume of one such shell, by summing up volume of all the shells, we can determine the complete volume of the onion or tumor inside of a human body. See, if of volume is very much important. For example, in case of tumor, if the size of tumor is smaller, then the clinical expert or doctor say that it's of benign nature, it's not of too much risky. But if the size of a tumor is bigger, a clinical expert will say that it's malignant, you should go for treatment as soon as possible. Therefore, the accurate measurement of volumetric information is highly recommended. So this can be done with the help of shell method. See, there are too many shells. So if on the x-axis, if I am talking each shell on the x-axis, so the thickness, this thickness, of course we are slicing up, it will give dx, and the height, okay, is gradually, if I am cutting from the bottom, of course height will different, cutting from the center height will different, at the top height will vary. So if we are unwrapping each shell, if we are unwrapping this shell, then of course we will get some kind of circumference of each shell. And of course from the top to bottom height, if the maximum height is A, and at each, okay, level height is varying, at ground level y is 0, so what will change in net height? We can say the height is representing final minus initial final is what? A, and initial is what? 0, or at this stage maybe it is in 1, 2, or maybe goes to A. So at each scale y is varying, so initial one we can say y, but if we are considering the different shells, see, height of the inner shell is different, height of the little bit central shell is also different, outermost shell is different. So in each case y is varying, so we can say we will use that the total maximum height is subtracted from some variable, that y is variable because we are summing up the volume of each shell and the height of each shell is also varying, so we are using a variable here, and this is giving us the height and now if I want to determine the volume of this half onion, so of course it is following some parabola, and this parabola is of course having some radius and revolving around some axis, and these axes you can say y-axis. So at each, okay, in reverse way, each shell is representing here, this one representing, or you can say in the reverse, vice versa, okay, it is representing dx. If we are unwrap the each shell, the circumference of each shell is represented with the help of 2 pi x. In case of height a, okay, this one is the suppose height and this one is the variation in height y, so height can be given a minus y. Now according to parabola nature, we see it can be represented with the help of y equal to x square, and if we integrate the maximum point, okay, we know at this maximum level, maximum height, y equal to a, so its range from bottom to, okay, top, we can say that if y equal to a and y equal to x square, so along the x-axis from this point 0 to at this position, this is the, okay, we want to determine, we have volume of each shell, or you can say that we want to determine volume into this curve. So of course it is revolving around the y-axis. We can say volume of one shell from 0 to x, and here we will have circumference 2 pi x, 2 pi x, and height, and dx thickness of each shell, and we know the volume here, this x, okay, this x can be written as x square equal to a and x equal to plus minus a, or in case of this we are meaning the length and it is always positive, therefore from 0 to, in this situation, x is strictly increasing from 0 and maximum scale, you can say that range is strictly increasing to the some variable and it will be the positive value of square root. So we will have volume 0 to square root a, and here we have 2 pi x, and in terms of height we will write a minus y dx, and due to parabolic nature we will write, or we will substitute the value of y as x square. Therefore on integrating it, we will have here, we will multiply this x with a, it will become, on integration it will become ax square over 2, with this it will become x cube over 4. This will, on this x here, where on this integration of x is x square over 2, and integration on multiplying this x with this x square, it will become x cube, and integration of x cube is x power 4 over 4. So we will write here four over 4, of course, and its range 0 to a. By substituting value, we will get a, by square root we will get rid of square root with this square, and we will have only a minus, here we will have a square further we will have 2 pi a square over 2 minus a square over 4. On further simplification we will get 4 a square 2 pi. So answer is pi a square over 2. This is volume of. I would like to introduce another feature in this volumetric, in this parabolic glass. For example, we have this one, and we are filling it with water. Suppose it's very cold weather like nowadays, it's winter, outside temperature is almost 0 degree centigrade, outside temperature, let me represent temperature with T, capital T, so it's 0 degree centigrade outside atmospheric pressure and normal atmospheric pressure. We want to boil this water. Of course, at this bottom point, T equal to 100 degree centigrade, due to colder weather outside, or you can say that outer weather is at 0 degree centigrade, and with the passage of time the water temperature is increasing, but not exactly like its bottom, and the final temperature at top level is 70 degree centigrade. Now there are three variations of temperature. You can say at the bottom it's 100 degrees centigrade, at the top it's 70 degrees centigrade, and at each instant, remember here we cannot use the method of shells. Method of shells basically it's working like this, but here the applicable method which can analyze the temperature of water can be done with the help of disk method, because the space at the bottom of this parabolic ball is too small, so the method of disk will work. Temperature is uniform for each disk, therefore we need to analyze the temperature, and this variation of temperature is determined. This variation of temperature can be noticed as final minus final. This is a change along the y-axis. Okay, of course at the bottom point it's the fixed thing, but with the variation in height, this variation in height, temperature is changing, and this change is happened from 100 to 70 degrees centigrade. So we will have 100 minus 30 degree variation of temperature, because this 30 degree change, this net change is happened or concluding with change in y. And remember, let's label some height to our system. See, the radius is 1 meter on each side. Okay, radius of this at the upper layer, and the height of this ball is also 1 meter. So average change in this water temperature can be done with two ways. One is the ordinary way. The question here, what is the average change in temperature of water according to the given condition? To given condition. First one is the ordinary way to determine the average change. What is this? The ordinary way to determine the average change is maximum temperature plus minimum temperature divided by 2, that's 100 plus 70 is the temperature at top of the water, so divided 2, that is the 85 degrees centigrade. The other one is temperature. The other way to determine the temperature, it can be done with the help of temperature of volume and with given condition, and here the total amount of volume, total volume of water in the both. Of course ball is the same, okay, here the volume here, but in the numerator it's the product of temperature and volume. In the denominator it is only the volume of water in that ball, the parabolic nature of ball, which is following the y equal to x square. Remember, it is following the y equal to x square. So now I am considering the numerator of this equation 2. For this, we see the range is from bottom to top. 1 meter is height of the ball, that is the 0 to 1 meter, and of course temperature. Here we have pi. Of course, each disc is representing the circular pattern or the surface area of each face of area of each disc can be done with the help of pi x square, and height of each disc is gradually changing with respect to incremental volume dy, or dy is the thickness of each disc in terms of vertical axis. So now we also know that T is the total, or you can say the change in total temperature in the bowl, and where the 30 degree 100 is at the bottom and 30 degree is variation till to the top, and where y, if y is the maximum height, if y is representing 1 meter, then of course the top temperature, if okay, in the top temperature when the height y equal to 1, it will become 100 minus 31, that is of course 70. So this is the basically variation of temperature, and we know due to parabolic nature x square equivalent to y, we will write here 0 to 1, so value of this 100 minus 30 y and x square y dy. On further integration we will get, okay, this y square here our 2, so basically this pi is there, so 50 pi y square minus 10 pi y cube, and range is 0 to 1, that is the height of the ball from 0 to 1. So on further calculation we will get 40 pi, that is the volume with respect to temperature, and if we are considering the average change in volume, we need to also determine the denominator. Here we need to determine the denominator, in this case total volume of water, total volume of water total volume of water can be determined as 0 to 1 pi x square dy. We know x square representing y, so 0 to 1 pi y dy, pi y square over 2, 0 to 1, and answer is pi over 2. This is the total volume of water, in that parabolic bowl. So substitute it here in this formula. This is the numerator, average change in water temperature, equal to temperature variation of water divided by total volume of water. We know total variation, temperature variation of water equal to 40 pi. This is the temperature variation of water, 40 pi, and the total volume of water equivalent to pi over 2. Pi over 40 pi temperature variation of water divided by total volume of water, pi over 2. This will be cancelled out and we will have 80 degrees centigrade. Therefore, this is the average change in water using the integral, or you can say method of disk. (80 degrees centigrade) is different than this 85 degrees centigrade. This is the ordinary way to determine the temperature, and it is very much important in some scenario where slight variation in temperature, for example, our car is heating up, it can be damaged permanently if we cannot notice it amicably. Therefore, slight change in the temperature is very much important. Tremendous attention is required to this change in temperature. That average change in temperature that can be determined with the help of precise measurement by using the method of disk is highly recommended. Temperature is determined with the help of ordinary method. It can damage the engine on permanent basis. Therefore, volume of our water inside of a radiator and its variation of temperature can be highly recommended to determine method of disk in order to achieve the maximum efficiency of the engine. It is not only in the cars, in many other instruments.